Hello my dear students, welcome to my channel. I am Shumit and this is my lecture number 6 on polar coordinate system. In my previous video, that is in lecture number 5, we derived the equation of conic in polar form and also we derived the equations of its direct basis. So if you have no idea about the polar equation of conic, you can check out that video. And in this session, we will derive the equation of chord passing through 2 points to a given conic, and we will also derive the equation of tangent. Okay. So without any further delay, let's move forward to the discussion. Now, there is a conic whose equation is given as L by R equal to 1 minus E cos theta. So, the focus of the conic is taken as pole and the initial line, the positive direction of initial line Sx is taken in the right direction. Now, chord passes through 2 points P and Q on the conic and we have to derive the equation of this chord. Okay. So, two things are given here, that is the vectorial angle of these points P and Q. Okay. So this is alpha minus beta and this is alpha plus beta. So let us assume that the coordinate of point P is r1 comma alpha minus beta and the coordinate of point Q is r2 comma alpha plus beta. Okay. So now we have to derive the equation of this chord. Now chord is a straight line, so we can think its equation, we can assume its equation as, say, PQ, the equation of PQ is given as L by R is equal to A cos theta plus B sin theta. Okay. Now, if you can remember, probably in my lecture number 3, when we derived the equation of straight line in polar form, I told you there that here we write a constant. This is a general form of the equation of a straight line. Now here we write a constant, any constant depending upon the situation. So here we use this constant, obviously L is the length of the semilattice rectum of this column. Now A and B are constants which are to be determined. So if you can find the values of A and B and put this in this equation, we'll be able to derive the equation of the chord. Now say this is our equation 1. And this is our equation number 2. Okay. Now, if you observe at point P is a point on the conic, so it must satisfy equation 1, and P is a point on the chord also, so it will satisfy equation 2. Now, we will put this value of P in this equation 1, so we obtain L by R1 is equal to 1 minus E cos the vectorial angle of P is alpha minus beta, so E cos alpha minus beta. And if we put P here in this equation, we get L by R1 is equal to A cos alpha minus beta plus B sin alpha minus beta. These are two equations. Now we can compare these equations. So we can write here, this implies A cos alpha minus beta plus B sin alpha minus beta is equal to 1 minus E cos alpha minus beta, 1 minus E cos alpha minus beta. Okay. Now students, similarly if you observe Q is a point on the conic and Q is a point on the chord, so this will satisfy both the equation number 1 and equation number 2. So similarly we get A cos, if you put the value of Q in these two equations, you will obtain A cos alpha plus beta plus B sin alpha plus beta is equal to 1 plus E cos, this is 1 minus E cos alpha plus beta. Okay. So these are two equations, two simultaneous equations we obtain, and if you solve these equations by cross multiplication method or any other method which is preferable to you, so you will find the value of A and B. Okay, so now I am going to the overall solution of these equations. I hope you can do it yourself. But if you have any doubts regarding cross multiplication method or the solution of simultaneous equations, you can ask me in the comment section. I definitely bring a separate video on that. So many students can think why sir is telling this because this is a very basic concept and we probably will learn this in our class 9th or 10th. It's good if you know that it's well, but I've seen in many students that they are studying B.Sc honors, but still they do not know this very basic method. So it's not a matter of shame, okay? You can forget, obviously you can forget. We all are human. So if you want to learn, comment me. I'll definitely make a separate video on that, okay? So if you solve these two simultaneous equations, you will obtain the value of A and B. That is A is equal to cos alpha sec beta minus E and B is equal to sin alpha sec beta. Okay, and leaving this on you, you will solve this on your own. Now just put these values of A and B in this equation 2 and you will obtain the equation of the chord. Okay, so if we put these values here in this equation, we get L by R is equal to, in place of A we will write cos alpha sec beta minus E into cos theta plus, instead of B we will write sin alpha sec beta into sin theta. Okay, now take sec beta common from these two terms and we will get, this implies, if we take sec beta common, then we are left with cos theta cos alpha, cos theta cos alpha, plus here if we take sec beta common, we are left with sin theta sin alpha. Okay, so plus sin theta sin alpha, and this is minus E cos theta, minus E cos theta. Now this is cos theta cos alpha plus sin theta sin alpha. This is the trigonometric formula for the expansion of cos A plus B, cos A minus B, that is cos A cos B plus sin A sin B. So we can write here the equation of the chord PQ becomes L by R is equal to, this is cos theta minus alpha into sec beta, cos theta minus alpha into sec beta minus E cos theta, minus E cos theta. So this is the required equation of the chord PQ. Okay, the chord passes through 2 points to a conic L by R is equal to 1 minus E cos theta, and the vectoral angles of those points are alpha minus beta and alpha plus beta. Now one more thing is that if the equation of the conic is given here as 1 plus E cos theta, then we will just make a little change here, that is in this sign. We will write here cos theta minus alpha into sec beta plus E cos theta. Okay, and you know this is the equation of a conic whose initial line, where the initial line is taken in the left direction. Okay, so you have to remember both these cases. For now, we just derive the equation of conic, equation of chord, and this is the equation. Okay, now we'll move forward to derive the equation of the tangent. So here I will mention two terms, that is, one is tangent and the other is secant. Now students, secant is basically a chord. Secant is nothing but a chord. A secant is a straight line. If we talk about straight lines, secant is a straight line which cuts a conic at 2 points on its circumference. Okay, this is a chord and this is called a secant since it intersects the conic at 2 points. So this is called a secant. But a tangent is a straight line if we talk about line tangents, because tangents can be not always necessarily it should be a line tangent. No, it's not. But however, we are now talking about line tangents. So tangent is a line which touches the conic at one point. Okay. So just think, if we shift this chord here, then this becomes a tangent since this touches the conic at one point. Okay, and here these 2 points P and Q coincides together and becomes just one point. So it will have only one vectorial angle. It means that this alpha minus beta and alpha plus beta, alpha minus beta and alpha plus beta will be equal in that case. Okay, alpha minus beta is equal to alpha plus beta. So we obtain that point is alpha. If we put beta is equal to 0, we get only one point, that is alpha. Now many students can ask that why beta is equal to 0, why not alpha is equal to 0? It's very easy. If you put alpha is equal to 0, you will obtain again 2 points. One is plus beta and the other is minus beta. So it will not become a tangent at all. So we have to put beta is equal to 0 here so that we can obtain only one point and it becomes a tangent to the conic. Okay, so that if we put beta is equal to 0 in this equation, we will obtain the equation of tangent. Okay, so the equation of tangent is L by R is equal to cos theta minus alpha into sec beta. So beta is equal to 0. So sec 0 is equal to 1. This minus e cos theta. This is the equation of tangent to the conic. L by R is equal to 1 minus e cos theta. And the point of contact, the vectorial angle of point of contact, if this is the conic and this is the tangent, this is the conic and this is the tangent. So this is the point of contact. So the vectorial angle of point of contact is alpha. Okay. So and if the equation of the conic is given as L by R is equal to 1 plus cos theta, we will just write here plus instead. Okay. So you have to remember these cases. Now we will move forward to solve some questions. First, we note it down and we will screen here. Okay, students, this is the problem which I gave you as a homework question in my previous video, and you will also find its solution in the PDF notes which was attached in the description box of that video. However, let's solve this problem together. So, find the respective polar equations of the right and left branches of the hyperbola 9x square minus 16y square is equal to 144. So, first of all, we'll reduce this equation into its standard form. So, if we divide both sides by 144, we obtain x square by 16 minus y square by 9 is equal to 1, which implies x square by 4 square minus y square by 3 square is equal to 1. So here a is equal to 4, a is equal to 4 and b is equal to 3. Okay. So we can write its eccentricity. This is the standard form of the equation of a hyperbola. I hope you know this from conic section. Okay. So we can write its eccentricity is equal to root over 1 plus b square by a square. This is the formula for eccentricity. From here we get root over 1 plus 9 by 16, that is 25 by 16, so 5 by 4. Okay, eccentricity. This is the eccentricity of the hyperbola. And the length of semilateral septum, small l, is given as b square by a units, that is equal to 9 by a is 4, so 9 by 4 units. Okay. Don't worry, I'll bring a separate video series on conic section also. So this is the eccentricity and this is length of semicircular. Now we can write the equation in its polar form. But here comes the concept of right and left branches. Here we are asked to derive the equations of right and left branches of the hyperbola. So if you draw a hyperbola like this is its right branch and this is the left branch. When we derive the equation of right branch, we will take the positive direction of initial line in right direction. But when we will derive the equation of left branch, we will take the initial line like this. Okay. So you know the equations. The equation of right branch will be right branch will be given as L by R. Since we are deriving the equation of right branch, we will take the positive direction in right. Okay. So the equation is L by R is equal to 1 minus E cos theta. This is the equation in that case, in that situation. So here L is 9 by 4 and E is 5 by 4. Just replace this values here. 9 by 4 and 5 by 4. So this is, you can write 9 by 4R is equal to this. If we multiply both sides by 4, we get the equation of right branch. That is 9 by R is equal to 4 minus 5 cos theta. Okay, this is the equation of right branch. But when we derive the equation of left branch, we will take the initial line in left direction. So the equation will become like this. Left branch (9 by 4) is equal to 4 plus 5 cos theta. Okay, so these are the answers. Note it down. Okay, students, next problem. Show that the condition that the straight line this may touch the conic this is this. This is asked in CHU 2016, probably in Central University of Haryana. Let's solve it. So we are given the equation of the conic. Say this is our equation 1, and the equation of the straight line. Say this is our equation 2. Okay. Now we can write the equation of a tangent which touches the conic at one point, and the vectorial angle of point of contact is alpha. Okay. So the equation of tangent is L by R is equal to, we just derive cos theta minus alpha minus E cos theta. This is the equation of tangent. Now we will reduce this to its general form, means general form of the equation of a straight line. So we get 1 by R is equal to, first let it be L by R. If we expand cos theta minus alpha, we get cos theta cos alpha plus sin theta sin alpha minus E cos theta. This. Now take cos theta common from these two terms and you will obtain L by R is equal to cos alpha minus E into cos theta plus sin alpha into sin theta. Okay. Now divide both sides by L. Then we get, since L not is equal to 0, we can divide both sides by L. We get 1 by R is equal to this constant cos alpha minus E divided by L into cos theta plus sin alpha divided by L into sin theta. Say this is our equation number 3. Okay. Now this is the general form of the equation of a straight line. Now we come to the equation 2. this is the straight line which touches the conic at one point. So it becomes a tangent to the conic. So this equation is comparable to this equation, and comparing both the equations we can write this is a constant which is equal to A and this constant is equal to D. So we get A is equal to cos alpha minus E by L, cos alpha minus E by L, which implies cos alpha is equal to AL plus E. AL plus E. Okay, this is cos alpha. And similarly, B is equal to sin alpha by L. So it implies sin alpha is equal to BL. Okay. Now just eliminate alpha from these two equations. So we'll square and add these equations together. Okay. So squaring and adding, we get A squared plus B squared is equal to cos alpha minus, say this is 4, equation 4, and this is equation 5. Okay. So squaring and adding equation 4 and 5 we get cos squared alpha plus sin squared alpha is equal to AL plus E whole square plus BL whole square. This implies AL plus E whole square plus B square L square is equal to 1, which is the required condition. Okay, this is the required condition, hence true. Now note it down. Okay students, now I am not adding more problems in this session since the video is going very lengthy. But don't worry, I will bring separate videos on problem solving at the end of this series. And here are two homework questions. I hope you will solve this on your own. And I will also discuss the solution in my later videos. So this is all for today's session. If you have any doubts regarding the discussion, let me know in the comment section. Also for the PDF notes of this session, check out the description box below. And thank you for watching. Keep studying and keep growing.